we're going to talk about measuring voltage and the communication line voltage to try to determine if there's a problem or not. So the first thing you're going to want to do is disconnect your power. You're going to need a 3mm Allen wrench. You're going to remove all 4 bolts from the front. And then typically what we recommend is you use the right 2 bolts and secure the lid to the left side of the box. One thing to remember when you're doing this is be careful, because there is a ribbon cable that goes from the membrane to the communication board right here. If it does become disconnected, no worries, it's easy to put back in and nothing's going to happen. All right, so at this point we've got the monitor open. You can see the communication board and your 3 motor boards. On the top of your communication board is a blue and white wire. That is our communication lines. We use RS-485 for this series of monitor. And the nice thing about that is it is only 2 wires and it has a reference voltage of right around 3.2 volts to ground. So with that in mind, it makes troubleshooting a little bit easier, trying to go back on the system and find out what's wrong. So in this scenario, we're going to assume that the monitor is working locally, but there's something else on the system that's causing us problems. So what we'll do at this point with power still off is we're going to disconnect the blue and white wires. Again, that's our communication lines. So now that means this monitor will not communicate with anything else on our system other than the wireless controller. Okay, so we've got the communication lines disconnected. We're going to go ahead and apply power. Okay, as you can see here, the power LED is on solid. That's a good thing. And you'll see on the motor boards, all of them but the nozzle is flashing, which is okay because there's not a nozzle connected to this monitor. So basically at this point, you're going to go through and test the monitor and make sure you've got functionality. All right, so now we know the monitor is good, so the problem must be somewhere else in the system. What we're going to do at this point is turn off power. And we're going to plug our communication lines back in. Okay, on this system, we've got a monitor, we've got an interface box, and a joystick. Once again, these are all communicating through the blue and white communication lines. And our reference voltage of the communication line, once again, is 3.2 volts. And that's reference to ground. So let's go ahead and put power back to the monitor. For this next step, you will need a multimeter capable of reading DC voltage. Typically, you're going to want to be able to go into 12 volt or 24 volt, and you're going to set it to the DC volt settings. All right, so once again, blue and white are our communication lines. So we've got the incoming lines from the monitor. They go over here to a bank, and as you can see, they branch off in many directions. One set goes over here to the circuit board. Now, once again, to isolate your voltage, you have to turn off power, remove your communication plug. In this case, you simply pull it up, and now you'll see the board is isolated from the rest of the system. Now you're ready to power it back up. And once again, measuring with your reference to ground, you're gonna go from your ground terminal to your communication lines directly on the circuit board. And you see we're getting that voltage of 3.2 volts. So we're good here. This is a redundant type system. So what that means is the board's labeled white, blue, white, blue. The whites are tied together on the board and the blues are tied together. At this point, what you'll want to do is, we know this board is good. So now with the plug still disconnected, we're going to measure from ground once again to whatever wires are plugged in. So in this case, you'll see we're at 3.2 volts, so we're good on there. And you move over to the blue wire and it's at 3.2 volts, so we're good there. So what does this tell us? We've already confirmed that our board's good, and we've confirmed wherever this plug goes is good as well. So at that point, you would just trace it out back into the system, and you would keep isolating components one at a time until you find the bad component. So let's say we measure from ground to the pins on the board, and let's say blue is 3.2, then you move to the white and it's 0 or it's a low voltage. What that tells us is the problem is the circuit board. As a double check though, to make sure there's nothing else going on in the system, go ahead and measure your wires in the connector just to make sure you've got the 3.2 volts. If the connector is bad as well, that means you have to trace the communication wires wherever it goes next in the system. It could be a joystick issue or it could be a monitor issue. You would just do the same procedure as far as isolating your communications from the next device, cycling power when you disconnect it, and measuring your voltages.